Okay, so this section is all about solving. So when we solve, we want to get the radical by itself. So I'm going to go ahead and do all the ones with radicals first. So starting with number 22. I've got the radical, cube root, x plus 1 on the inside, 3 on the outside. So I get rid of the 1 on the inside first by dividing. So I have cube root x plus 4 equals 12 divided by 3 is 4. So once we have the radical isolated so that there's no numbers on the outside, we can actually just raise it to the exponent that matches the index. So it's going to be to the third power for this one. So 4 to the third is 64. X plus 4 is now out of the cube root, and now I just subtract both sides by 4. So x equals 60 is our possible solution. So just to be sure, we go back and check. 60 plus 4 is 64. Cube root of 64 is 4. And then 4 times 3 is 12. So that checks out. So that is the solution. It's really important that you always go back and check. See, I got another one with a radical right here. Okay, so if I have a radical, I need to raise it to the exponent of 2. So on the left side, it's just 2x. On the right side, you have to write it out twice. So this means x minus 4, x minus 4. So when we FOIL that, it's x squared minus 8x plus 16. To solve this, we have to subtract 2x so that the problem is equal to 0. So we got 0 is equal to x squared minus 10x plus 16. So this is a simple ABC. 1 and 16, 2 and 8, 4 and 4. Try to make a negative 10, so it's got to be this one. It's got to be minus minus. So we have x minus 2 and x minus 8 equal to 0. So that means x equals 2 and x equals 8. So we just go back and double check. If I put in the 2 right here, 2 times 2 is 4. Square root of 4 is 2. If I put in the 2 right here, 2 minus 4 is negative 2. So that actually doesn't work. So this one is extraneous. And I go back and I double check if I was to put in the 8. So if I put 8 right here, that's 16. Square root of 16 is 4. If I put in 8 over here, 8 take away 4 is 4. That works out. So this one's okay. The problem was 28. Looks just like it. Just got to just square it. Square this side. So on the right side, it ends up being x squared plus 6x plus 9 because of FOIL. And on the left side is 7x plus 21. Then we have to subtract 7x from both sides. Subtract 21 because I want it equal to 0. So 0 equals x squared minus x minus 12. It's another simple ABC. Two numbers that multiply to 12 but give me negative 1 would be negative 4 and plus 3. So that means x equals 4 and x equals negative 3 are the possible solutions. Go back and check. 28 plus 21, so 7 times 4 is 28, plus 21 gives me 49. Square root of 49 is 7. If I go ahead and plug in 4 right here, 4 plus 3 is 7, so it checks out. So this one's okay. So ugly check mark. Then we go back, double check. I'm going to check the negative 3. So if I put in a negative 3 here, negative 21 plus 21 is 0. Square root of 0 is still 0. Negative 3 plus 3 is 0. So 0 equals 0 works out also. So this is okay. Okay, let's see what we got here. We'll do this top one first. So we want the square root on different sides. So I need to add it to the other side. So it's going to be a positive 3 square root x minus 2. And then on this side, we have x squared minus 2x, all in the square root. So these are basically like the last two that I just did. We just have to square it and square this. So the part where you're going to have to be careful is this exponent applies to this number right here. So that's actually 9. And then when you apply it to the radical just goes away. So it's x minus 2. And on the other side, we have, just makes it go away. So it's x squared minus 2x. So we distribute 9x minus 18, x squared minus 2x. And then we need everything equal to 0, so I subtract 9x. And I add the 18. So we end up with x squared minus 11x plus 18 equals 0. Simple ABC, two numbers that multiply to 18 and add to 11 is negative 9 and negative 2. So that means that x equals 9 is a possible solution and x equals 2 is a possible solution. So we go back and check. If I plug in 2 on the left side, or on the original problem, this gives me 4. 4 take away 4 is 0. And then I plug in 2 in this one. 2 take away 2 is 0. 0 times 3 is 0. 0 take away 0 is 0. So that works. So 2 works. We check 9. We have 81 minus 18. So we end up with the square root of 63 in this one. And then if I plug in 9 right here, 9 take away 2 is 7. Then I have the 3 in front. Now, the thing about the 63, though, is if you were to type in 63 into your calculator, you'll see that it actually is 3 square root 7. So when you take 3 square root 7, take away 3 square root 7, it gives you 0. So that one also works. Those are 2 solutions. Okay, this one, it's already got the radicals on different sides, so we can just raise it to the third power. So 120x plus 30 comes out. 240x minus 10 comes out. This is a simple algebra 1 question now. We take the x's to one side, so I subtract 120x. So I took all my x's and I moved them to the right. So that's 120x. Then I'm going to go ahead and add the 10 to this side so I can separate them. So that gives me 40. And I just divide by 120. So x is 1/3. And if you go back and check that, 1/3 of 120 is 40. 40 plus 30 is 70. And then 1/3 of 240 is 80. 80 take away 10 is still 70. So it works out. That's your answer. Now in this one's a little different because it's got the radical and it's got some stuff on the outside. So I need to get that out of there first. So that's 11. This is cube root x minus 4. So we're going to raise this to the third power. So 11 to the third is 1331. Now x minus 4 is out, so we can add the 4. So it's 1335 for x. So if you go and plug in 1335, take away 4 is 1331. Cube root of 1331 is 11, and 11 plus 7 is 18. So it checks out. So this is the correct answer. And now we're going to go back and do all the ones with exponents. So the exponent idea is pretty much the same idea. We want the parentheses without the numbers on the outside. So the first thing is to get rid of the minus 2. So that gives me 5. So I have 2x plus 15 to the 1/2 power. So if I want to get rid of the 1/2 power, I just raise it to the power of 2, or 2 over 1, which is still 2. So these cancel, and now I have 2x plus 15 equals 25, and I can just solve it like normal. So I subtract 15. This is 2x equals 10, divided by 2, and x equals 5. Now we still have to go back and check it. If I put in a 5 here, 5 times 2 is 10, 10 plus 15 is 25. Square root of 25, because that's what 1/2 power means, is 5. 5 take away 2 is 3, so it works. We have the exponent of 1/4, so we're going to raise that to the 4th, raise that to the 4th. So we have 57 minus 4x equals 69 minus 2x. All of the x's need to go to one side, so I'll add 4x to both sides. Oh, this is 57. I was getting thrown off a little bit. So this is 2x. Then I'm going to subtract the 69 over. Subtract 69. 57 take away 69 is negative 12. So this crosses out. So we just divide by 2. So x equals negative 6 is a possible solution. So if we go in the calculator, 57 minus 4 times negative 6 gives us 81. If you take the 4th root of 81, the answer, kind of messed up on the calculator here, hang on a second. 4th root of 81 is just 3. So one side gives us a 3. So if I do 69 minus 2 times negative 6, gives me 81 again. And if I take 81 to the 1/4 power, it's still 3. So it works out. So that's our answer. So I think that's it for that page. That's all the stuff that has radicals. Radicals and exponents that are fractions. The reason why they're grouped together is because fractions in the exponent spot means they're radicals. And that's what you're supposed to learn in this chapter.